Hello Math 8 students, this is Open Up Resources, Unit 4, Lesson 4, More Balanced Moves. To get started we have an equation, and we can see that two students have solved the equation. They've solved it in different ways. The equation is 14x minus 2x plus 3, which is equal to 3 groups of 5x plus 9. These are the steps that Claire took to solve it, and these are the steps that Lynn took to solve it. We're wondering, are both of their solutions correct? And explain your reasoning. The next question is describe the ways that they solved it, describe the steps that they took, how are they alike and different. So in order to answer both questions 1 and 2, we really got to take a nice detailed look. This is what I would suggest. Look at each row and then see what changes were made to go from one row to the next. For example, what change happened to go from this top row here? Nothing happened on the left-hand side, but we can see a change was made here. Identify what that change is and go through that step by step. Do that for each person. You're going to do that as you pause the recording and identify what steps were taken so that you can answer, are both of their solutions correct? And what steps did they take? How are they similar and different? Pause the recording now. This is what I see. On this first row, I don't see any change at all on the right-hand side. Everything stayed the same. But on the left-hand side, I can see that 14x minus 2x was combined to be 12x. So I'm going to write that here off to the side. Here we combined the x tiles. Now I have 12x plus 3, which is equal to 3 groups of 5x plus 9. I can see that I still have the same thing on the right-hand side. So no changes were made on the right-hand side, but something interesting happened in this step here on the left-hand side. It's a step that we normally have not taken in class. So let me explain what's happening. We have 3 groups over here on the right-hand side, and so they decided, what if we were able to break up 12x plus 3 into 3 groups? That's called factoring, when we break up our tiles into groups. Normally we're focused on getting them out of groups, but this step they decided to break into groups, also known as factoring. So if 12 x tiles are split into 3 groups, that means I'm going to have 4 x tiles in each one of those groups. And if 3 unit tiles are broke up into 3 groups, that means I will have 1 unit tile in each of those groups. And now we can see a change is happening on the right-hand side, and a change is happening on the left-hand side. When you look really carefully, you can see that that change is we had 3 groups on each side, and now we are down to just 1 group. So we must have divided each side by 3. This is our first official solving step. All the remaining steps were just simplifying steps. Now that I have divided each side by 3, I can see I did have 4 x tiles. Now there are no x tiles. I had 5 x tiles. Now I have only 1 x tile. So it looks to be that the step that was taken here is we subtracted 4x. We did the same thing over here to the other side. And now there's just one solving step left. I had an x tile and 9 unit tiles. Now I have just an x tile, so I must have subtracted 9 from each side. 1 subtract 9 is equal to -8. Here's how Lynn solved it. It appears that they took the same first step, because 14x minus 2x is now written as 12x. So it looks like they simply combined like terms, combined those x tiles. There is no change over here on the left-hand side now. Nothing changes here, but the right-hand side is changing. Did you identify what that step was? It looks like we have 3 groups of 5x written as 15x, and 3 groups of 9 written as 27. So it looks like they use the distributive property. Distribute the 3. And now it looks like in this next step both sides are changing. I had 12x plus 3 and now it's down to just 12x. So it appears I subtracted 3. On the other side I had 15x plus 27, but now there's only 24. Looks like that change was that we also subtracted 3. Everything seems to be going good. When I make my very first solving step, I am doing the same thing to both sides. And now I had 12x, now I'm down to -3x. Something changed here. I had 15x plus 24, and now I have just 24. So it appears, since the 24 is still there and the 15x is no longer there, it appears I must have subtracted 15x and balanced it to do the same thing on the other side. 12x minus 15x is negative 3x. And now our final solving step. X is multiplied by a negative 3, and it's no longer multiplied by a negative 3, it's just x. So I would undo multiplication with division. Let's see if the same thing happened over here. 24 divided by a negative 3 is equal to negative 8. So are both of their solutions correct? We have negative 8 is equal to x, and we have x is equal to negative 8. And the answer is yes, both of their solutions are correct. X is equal to negative 8 is the same as negative 8 is equal to x. We call that the reflexive property. We've talked about this in class before, as I've just shown the front side of the scale and then turned around, and we're just looking at the back side of the scale. So yes, their solutions are correct. They took different steps, but they got to the same place. So describe some ways the steps they took are alike or different. They both simplified the left-hand side first. But then the steps that they took started to change and become different. Claire factored or broke them into groups. While Lynn distributed and got them out of groups. All right, we've now seen two ways to solve this equation correctly. We're going to look at the work that we see below from Mai and Noah. Mai and Noah also solved the exact same equation, but they made some mistakes. So find the mistakes and explain why it is incorrect. Pause the recording as you take a look at Mai and Noah's work. As I go through this step by step, I can see that Mai took the same first step as everyone else. 14x minus 12x does combine, 14x minus 2x combines to 12x. So again, a great first step, we combined our x tiles. Then I can see that 12x becomes 5x. Let's look at the other side and I can see why. Here's the 5x, and in the step below, that 5x is gone. That is where the mistake happens. Can you understand why that's where the mistake happens? What I should have done is recognize that I don't just have 5x tiles. Those 5x tiles are part of a group. So I don't just have 5x tiles, I have 15 x tiles. Even if I try and remove 5x tiles from here, all I've really done is subtracted 5x tiles from one of those groups, but I would still have 5 of those groups that have x tiles. So here is the mistake. We cannot subtract 5x until we simplify first. We've got to get it out of the groups first. The rest of the solving steps were correct, but since we made a mistake so far back, we're not going to see any of that reflected in the answer. Noah, let's take a look at his first step. We have 14x minus 2x, which simplifies to 12x. But it looks like Noah also made a change on the right-hand side. Let's take a look at his change. He did 3 groups of 5x, which is 15x, and he did 3 groups of 9, which is 27. So it looks like on the left-hand side he combined his x tiles, on the right-hand side he distributed. In short, he just simplified each side in the same step. Now let's look at the next change. 12x becomes 27x. The 3 stays a 3. 27 stayed 27, and the 15x here disappeared. So it appears I subtracted 15x from this side. That's what made it zero out and go away. But on this side, 12 minus 15x is not 27x. It appears they subtracted 15x from one side and added 15x from the other side. Here's the mistake. Whatever we do to one side, we have to do the same thing to the other side. So if I'm going to subtract 15x from one side, I need to subtract 15x from the other side. Let's take a look at the next problem. Now it's your turn to solve equations, and you're going to make your own steps. Instead of following someone else's, we're going to make our own steps. So go ahead and try each one of these. I'll do each one in order in the recording, but pause the recording to give them a try first. On number 1, I have 12 plus 6x, which is divided by 3, and that's equal to 5 minus 9, which is divided by 2. My goal is always to try and simplify before I start solving. And I can see this is messy, but it's really just a numeric expression that I can simplify. 5 minus 9 is equal to negative 4, and negative 4 is divided by 2. Negative 4 divided by 2 simplifies to simply negative 2. So as crazy as this looks, this simplifies to negative 2. I can also simplify the left-hand side. Maybe you didn't catch that right away, and that's okay. But I would like to show you that 12 plus 6x is divided by 3, and 12 can easily be divided by 3, just like 6 can easily be divided by 3. So this whole thing is divided by 3, but it is okay to divide it in pieces. 12 divided by 3 is 4. And 6x divided by 3 is 2x. By taking the time to simplify both the left-hand side and the right-hand side, I took this equation that looked very intimidating, and now it's a very simple equation. Now we're just going to identify what's happening to x and undo that. X is multiplied by 2, and then we added 4, so I will undo those things. I'm going to subtract 4 from each side to balance it out, and 4 minus 4 zeroes out. That leaves me with 2x, which is equal to negative 2 minus 4 is negative 6. Next solving step, I'm going to divide each side by 2. And I have x is equal to negative 6 divided by 2 is negative 3. Let's move on to number 2. Number 2, I have x minus 4, which is equal to 1/3 of a group of 6x minus 54. Again, it might seem intimidating in the beginning, but if we just take the time to simplify before we try and solve, it's going to look much easier. I can't combine x and minus 4, so that is already simplified. But I can distribute the 1/3. 1/3 of 6x is 2x. And 1/3 of 54 is 18. Since I was subtracting in the parentheses, I'm going to continue subtracting when I am distributing. All of that is equal to x minus 4. And again, what was pretty intimidating has already been made much more simple. We can see I have x tiles on each side. I only want the x tiles to be in one place, so I'm going to subtract x and balance it, do the same thing to the other side. X subtract x zeroes out, and it leaves me with, be careful here, not just 4, but it leaves me with negative 4. And that's equal to 2x, subtracting an x leaves me with just a single x, minus 18. And we're one step away now. I undo subtracting 18 by adding 18. Balance it and do the same thing to the other side. And I have x, which is equal to -4 plus 18 is 14. And now on to number 3. The one thing that we need to be careful with here is really paying attention to this symbol right here. It didn't print nicely either on my screen or on your paper, but you can see it's 3x minus 12 in a group. Why is it in a group? Because that group is being turned to its opposite. So that's the first step that I'm going to take here. The opposite of 3x tiles is -3x tiles. And the opposite of subtracting 12 unit tiles is adding 12 unit tiles. That leaves me with -3x plus 12, which is equal to 9x minus 4. I can't further combine these. Each side is already simplified, so now it's time to move the x's to the same side. I'm going to zero out these -3x tiles by adding 3 positive x tiles. -3x plus 3x will zero out, but I'm going to balance it and do the same thing to the other side of the equation. Again, -3x plus 3x zeroes out, and I'm left with 12. 12, which is equal to 9x plus 3x is 12x minus 4. I have x is multiplied by 12 and then we subtract 4. I'm going to undo subtracting 4 by adding 4, balancing it and doing the same thing to the other side. 12 plus 4 is 16, and that's equal to 12x. And as my final solving step, x is multiplied by 12. I will undo that by dividing each side by 12. That leaves me with x, which is equal to 16/12. That is going to simplify to 4/3. Fractions are friends. As a decimal, that will be a repeating decimal, and that will not be very pretty, so fractions are friends. We have made it to the end of the lesson, so here is our Lesson 4 summary. The Lesson 4 summary talks about the potential for making mistakes when we're solving equations. We saw when Mai and Noah made a mistake, so we want to be able to check our answers. And the good news is anytime we take a step, the resulting equation is going to be equivalent to the original. So when I have solved this equation, 2x, which is equal to -3 times x plus 5, I've taken all these steps and I end up with x is equal to 3. I can check that answer as we've done in previous lessons, and I do so by saying, well, since x is equal to 3, anytime I see an x, I'm going to substitute in a 3. So I have 2 times x becomes 2 times 3. That simplifies to 6. I have -3 times x plus 5, and that changes to -3 times 3 plus 5. Well, 3 plus 5 in parentheses is 8. And 8 times a -3 is -24. And I realize I must have made a mistake because 6 is in no way equal to a -24. Now we need to go back and see if we can find our mistake. When we check our steps very carefully, we can see that we made a mistake right here. -3 groups of x is going to be -3x, but -3 times 5 is not going to still be 15. It is going to be -15. Redoing that step, I can see here is my new correct equation. Now, when I add 3x to each side, I'll still get 5x, but now I'm going to be left with not just 15, but a -15. I continue to solve, and now I have x is equal to a -3. This time, when I plug in a -3 into the equation, I have 2 times -3, which is -6. -3 times, in parentheses, -3 plus 5. Well, -3 plus 5 simplifies to 2. Multiply that by -3, and I also get -6. Now it is true. So, take the time to check your answers, and when you do, if you get a false statement, make sure you go back and check to see where your mistake is happening. Here's our cool down. Lynn solved the equation 8 groups of x minus 3 plus 7, which is equal to 2x times 4 minus 17, incorrectly. find the errors in her solution, and what should her answer have been. I don't even want to look at Lynn's work until I've done the work for myself. Anytime I need to find somebody's mistake, it's always best to know what I'm doing or what I would do to begin with. So I'm going to solve the problem for myself first. And I can see I can simplify this left-hand side. 8 groups of x is 8x, and 8 groups of subtracting 3 is subtracting 24. Don't forget we still need to add 7. I'll take that in the next step. And all of that is going to be equal to, in this one I'm not going to be multiplying across the parentheses because I want to simplify what's in the parentheses first. We normally have not had equations where I can do that, but this one I can. 4 minus 17 is equal to a negative 13. That takes care of those parentheses. And now those parentheses are multiplied by 2x. I'll take that in the next step. Here I can combine my unit tiles. Negative 24 plus 7 is equal to negative 17. I still have my 8x tiles, so I'm going to bring that down. And now the left-hand side is completely simplified. The right-hand side, I have 2x multiplied by a negative 13, and that is equal to a negative 26x. I have negative 26x. I have 8x. I want to combine them into one place. So I am going to subtract 8x tiles from each side. That way I no longer have them on the left-hand side. All I have left on the left-hand side is negative 17, and that's equal to negative 26x minus 8x is equal to a negative 34x. Just one solving step left. X is multiplied by a negative 34. I will divide that by a negative 34. That has been undone, and I have x, which is all by itself, and that is equal to negative 17 divided by negative 34, which is equal to a positive 1/2. Now I have correctly solved it. Now we can come back and take a look at Lynn's solution. Looks like Lynn ended up with something similar, but x is equal to a negative 1/2 instead of a positive 1/2. Let's see if we can find where those mistakes happened. Looks like the first step they took, they only focused on the right-hand side. And let's compare that to what we did on our right-hand side. We still have our 2x multiplied by parentheses 13. We did 2x multiplied by parentheses negative 13. I've already found the mistake. It looks like they lost their negative. They did not attend to precision. 4 minus 17 is a negative 13. Her answer should have been x equals 1/2, so we have completed our cool down. There is a great "Are you ready for more" problem. Let's talk about that one next. I have 24 pencils and 3 cups. The second cup holds 1 more pencil than the first. The third holds 1 more than the second. How many pencils does each cup contain? See if you can write an equation to represent this or draw a model. Pause the recording as you give it a try on your own first. Hopefully you've given it a try. Let's come back and take a look together. 24 pencils, 3 cups. I'm going to draw a picture. Here's the first cup. Here's the second cup. And here's the third cup. And all together, all of these cups have a total of 24 pencils. Here's my first cup, and it doesn't tell me how many pencils I'm going to be putting in here. Let's just call it P for pencil. The second cup holds 1 more than the first. So my first one holds P. That means my second cup is going to hold P plus 1 extra one. And the third cup holds 1 more than the second. Well, my second one holds P plus 1 plus 1 more. This is an equation. All I have to do is now get rid of those cups, which is not going to work out. And then I have simply P plus P plus 1 plus P plus 1 plus 1, which is just P plus 2. I've now rewritten this with parentheses instead of those cups, but I can see really truly if I took all of these pencils out of the cup, all of these ones out, and all of these ones out, that's no different than simply getting rid of those parentheses. So I end up with P plus P plus 1 plus P plus 2, and we can simplify before we solve. 1, 2, 3P plus 1, 2, and 3 means I have 3p plus 3, and all of that is a total of these 24 pencils. Very simple equation now. I'm going to subtract 3 from each side. That leaves me with 3p, which is equal to 21. And my final solving step, I will divide each side by 3. And that's how I get p is equal to 7. How much does each cup contain? Well, this one contains 7. This one contains 7 plus 1 for a total of 8. And this one contains 8 plus 1, or 7 plus 1 plus 1 for a total of 9 pencils. That's it for this lesson. Your homework is the lesson 4 practice problems. Thanks for watching. We'll see you next time.